Myself G. Satvika. I am from CSE department. Today my topic is Principle and Applications of IR Spectroscopy. Coming to the introduction of IR spectroscopy. What is IR spectroscopy? Infrared spectroscopy is the analysis of infrared light and interacting with a molecule. IR spectroscopy is the analysis of infrared light interacting with a molecule. This can be analyzed in three ways. They are by measuring absorption, emission and reflection. The main use of this technique is in organic and inorganic chemistry. It is used by the chemists to determine functional groups in molecules. It is an absorption method widely used in both qualitative and quantitative analysis. The infrared region of the spectrum includes electromagnetic radiation that can alter the vibrational and rotational states of covalent bonds in organic molecules. IR spectroscopy is a technique used to study the interaction of molecules with infrared radiation. It is based on the principle that different functional groups in a molecule absorb specific frequencies of infrared light. By analyzing these absorption frequencies, we can identify functional groups and gain insights into the molecular structure. And next, principle of IR spectroscopy. And we can observe the diagram here. IR spectroscopy relies on the vibration and rotational motion of molecules. When a molecule absorbs infrared radiation, it undergoes changes in molecular dipole moment, resulting in vibrational and radiational transitions. These transitions occur at specific frequencies corresponding to different bonds and functional groups. Infrared spectroscopy is used in areas of determination of molecular structure, identification of chemical species, quantitative qualitative determination of chemical species, and in a host of other applications. This technique is used in the investigation of matter in the solid, liquid, and gaseous states. Next, instrumentation of IR spectroscopy. The key components of an IR spectrometer are a light source, a sample holder, a monochromator, and a detector and a data display system. The most common light source is a heated nichrome wire, which emits a continuous spectrum of infrared radiation. The monochromator selects a specific wavelength of time, and detector measures the intensity of the transmitted light. And we can also see the diagram here. It contains a reference, monochromatic system, sample, splitter, director, readout. And next, coming to the IR spectral interpretation. IR spectra are typically displayed as a plot of percent transmittance or absorbance versus wave number. Functional groups absorb at characteristic wave numbers, allowing us to identify their presence in a simple. The intensity and shape of absorption peaks provide information about bond strength, symmetry, and molecular environment. And we can see the graph here, which is related to this interpretation. Applications of IR spectroscopy. What are the applications? What are the major applications? IR spectroscopy is widely used in organic chemistry for identification and characterization of organic compounds. It is valuable in pharmaceutical analysis to ensure the quality and purity of drug substances and products. It finds applications in forensic science, environmental analysis, material science, and even studying art and culture heritage. And here's the graph which is about most commonly used IR values in organic chemistry. Here are two peaks which is related to this graph, and one is broad peak and one is sharp peak. It contains 400 centimeter inverse to 4000 centimeter inverse, and we can see this. Next, coming to the advantages of IR spectroscopy. IR spectroscopy is non-destructive and requires minimal sample preparation, making it suitable for analyzing a wide range of samples. It provides valuable information about functional groups, molecular structure, and chemical bonding. It is a relatively inexpensive and widely available technique, with instruments ranging from handheld devices to high-end research-grade spectrometers. And here's the diagram. Next, coming to the conclusion. IR spectroscopy is a powerful analytical technique that provides valuable insights into the molecular structure and composition of materials. And I also want to add some top points to this. Infrared spectroscopy is an important analytical technique for determining the structure of both inorganic and organic compounds. It is also known as vibrational spectroscopy. IR spectroscopy lies between wavelength range of 0.7 to 400. With its wide range of applications and ease of use, it continues to be an essential tool in various scientific fields. It's based upon selective absorption of IR radiations by the molecule, which induces vibration of the molecules of the compound. IR instruments are of two types, namely dispersive instruments and Fourier transform IR instruments. Yes. Next, by hardening the principle of infrared absorption, we can unlock a wealth of information about the building blocks of matter. And the conclusion is completed. I also told about the applications and principles of IR spectroscopy. IR means infrared spectroscopy. Thank you, sir.